Okay, I'm just getting my displays all up, all that good stuff. Friend's gonna take a little bit to get here, but they will be around anon.
Also ran.
Yeah, I can't do that voice. Sounds too much like I'm trying to do my Pooh Bear impression, but making them edgy.
Christopher Robin also ran.
Something like that. And my phone is stupid. Not a good phone. I was trying to get my display on my phone. Not coming up. Either way. That is not the right one. Yokozo minasan. Hi hi. Yo. I plan on doing things today. Been usually working on my novel, but I wanted to work on something else today. I've been thinking about getting back into programming again, because I haven't really done programming in a while, and I feel like I'm just gonna finally jump into using Godot, trying to figure it out, see what it's all about, you know. I think my phone just like exploded. So I have a design document here. Probably right that it's actually a design document instead of just game design. So off to a good start already. Anyway, we have a bunch of stuff on here. Wow, did they really delete their name? I'll just put and H, even though that they put a thing there. Figured if it wasn't last names it'd be fine, but maybe I'll just get rid of these parts. Friendo don't want their name there. Won't be there. I'll just leave it as H. The proverbial H. So yeah, I wanted to start this project properly with an actual design document. I have another friend working on this with me. It will be the artist. I will be doing more of the technical side with programming. I'm going to try and lay down the bones, so to speak, and then they will make, you know, a little sprite work for animations and all that good stuff, so the game looks nice. None of us know how to make music, so might have to figure that one out. Let me see, what else was I looking at here? I wonder if I could make some decent looped tracks. But, let me get my Twitch display up on my phone. Finally, it's there. Yeah. Okay. Always stuff to set up, isn't there? Always stuff. There we go. Finally. Took long enough. Okay, okie dokie, artichoke. Let's get into this. So, inspirations. Survivors. Actually. I wonder if they list a genre for itself. Okay. Garlic collect. That's fine. I was gonna say, did they make it one word or two word? It's listed as one word, so should I assume that's one word? Roguelike. Well, doesn't really matter where I put that. You know what? I said they want to go down that far. I'll give them a few tabs. So, what do we want to look at first? Vampire Survivors. Can I get like a good screenshot of it? So. Do I want to include a reference sheet here? Or no? Part of my brain tells me I should probably include a reference sheet because I'm weird. Actually, wait. I can add that with this, right? Yeah, I can add a bibliography. There we go. I'm not doing anything fancy, so... Let's see. Citation, manage sources, new source. Don't need anything fancy schmancy. Boom. Vampire survivors. Wikipedia. No. Okay. Documentation is always important. Okay, so let's see. Oh, this is gonna be a process. I wanted to populate my table of figures a little bit though. Oh, wait. Can I make it not say the whole thing? Hang on. Oh, I see. Well, I guess it doesn't matter then. I was wondering if I could make it not say that. But, oh well, it doesn't matter. Okay, so let's start by looking at it. Survivors, it started its launch on itch.io, then meeting whale success was published to Steam. A cheap cost. Debate. Masterly debate. Also, just for the record, figuring doing the Survivor like, because it seems like it might be a decent ease of entry, potentially. It'll let us look at statistics as well as some simple UI, etc. We don't have to copy the UI word for word, but I don't mind minimalistic stuff myself. Let's see. See. Repetitive. Repetitive. I'm not dyslexic. You're dyslexic. One, two, three, four, five, six, seven. Seven. Does it have a... Probably want that one. Oops. No, those are the same ones. Okay, there we go. Trying to get all the pictures of the UI I can find. That one might serve better. Oh, we're another. That was the power-up screen, right? No, it's the collection screen. Collection screen. Yeah. Okay, there we go. Blah, blah, blah. Yeah, so we got 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. Yeah. Also, can I find the map selection screen? That's what I really would like. Map selection. Hmm. Let's see. Vampire Survivors. Map select. Okay. This works perfectly. Vampire Survivors. Map select. Screen. Map screen. What is this song? It sounds like One Piece music, but it's Pokemon. This is Pokemon Mystery Dungeon. Super Mystery Dungeon at that. Expedition Sesti? Is that a word? Siesti. Sounds wrong. Is it just written wrong? Study of the science jurisdiction. How do you... I guess it's a real word, but it doesn't look like it's one commonly used. Weird. Anyway. Lock selected. What was my power up map select, blah blah blah. Okay, let's see. UI is a little more dense than I thought it was, in some ways. Let's see. Sphere. It's the Sonic sphere. Yeah, this image will work. What? Maybe the image won't work. is main gameplay 1. Okay. Making design documents sure takes time. Okay, so main gameplay. Character. Yeah. One of the key things to know is Summer is most likely random before being slowed rather than. I think I'll put that there for now. So, what was the other name of the game? It was like 20 minutes. What? When did I last talk about that with my friendo? Man, I always tries to mess this up, doesn't it? You know what? I don't understand how it messes up with that part, too. Like, what are you doing? Core gameplay is intended to be akin to No Man's Sky. Or whatever. Okay. Maybe I should move this section to the other one. I don't know. I feel like this section might be better in the other end. Though, I mean, I guess I can double up. It doesn't really matter. Uh... When was the last time I updated Godot? I always call it Godot, but I'm pretty sure they always call it Godot. They call it Godot. It's like I'm Godoting all over the place. I'm like, what are you talking about? Why are you Godoting all over the place? Where is my Godot stuff? I don't remember. I didn't save it over here, did I? I would like to make sure everything's on, like, the same hard drive and or SSD, just to make that a little cleaner. Well, if I didn't before, I'm gonna do it now. Oh no, I made my thing disappear. Wait, don't accept, I'm not lying. Did you just write that now, or has it been a second? Let's see. Trying to get some stuff set up here. If I can. I really don't want to use Blender again. Blender sucks. It's not that bad. I just don't like it that much. Run anyway. OpenGL, blah blah blah. Create new project. Let's see. Folder. Okay, we want to name this Unentitled Fury. Perfectly fine. Supports desktop platforms only. Advanced 3D graphics available. Can scale to larger, complex screens. Uses rendering device backends. Slowly rendering. Sounds like we want compatibility. Supports desktop, mobile, web platforms. Least advanced 3D graphics. It's headed for low, older devices. Version control metadata. Probably GitHub is always fine. I feel like it would be better to go with compatibility for mobile devices, but and it would support web platforms, so I feel like that'd be better. I don't think we need, you know, amazing 3D graphics for this, since it's not supposed to be 3D anyways. I think ideally we probably want this project to run on a potato, so I think that'll be fine. I guess we can change that as needed in the future, perhaps. Perhaps and perchance. Okay, so I haven't done this in a while. Can I put this on game capture or no? I don't think I can. Oh, no I can. Cool. Well, here's this. I was curious if we could actually have that up or not. So there, we can have both of these up at the same time now. Kind of. I do want to check. Do I have my account set up? Plugins are available in the project. Install VC. Do I have to like set up GitHub myself? Excuse me. Getting all the sniffles. So yeah, this has a scripter in it by default, which is interesting. I haven't played around with Godot too much yet, but I know a lot of it's similar to Unity. They tried to make it similar on purpose, because they wanted a free-to-use engine that's similar to Unity, but, you know, not scummy. Not scummy. So ideally we could do a bit with this. I'm gonna definitely have to figure out stuff. I guess the first thing I'll look is how to connect Godot with GitHub. Use it with commands or user interface. Godot also has integrated version control system. The projects button in the editor, which lets you stage and commit changes. I don't know how their version control works on this yet, so that is also a thing to learn, They have a console that you can just use too, I guess. No? Keep clicking the wrong thing. Find files. Okay, so they have a finder. That's kind of nice. Let me actually check. Projects. I mean, they have a get ignore right here. Ignore editor. That doesn't mean anything. Yeah, this might be helpful. Learn how to use GitHub on Godot project in 5 minutes. We use the free version. Anchor points push or pull files to GitHub. I mean... Track project as zip, install Android build templates. That's what that one says, so do I have to set that up? Version control is cornerstone of your workflow with Godot. I'm just gonna keep calling it Godot, even though it's Godot, and I know it's Godot. Game engines do not understand incremental savings, and you don't want to copy and paste your backup files on your desktop. Version control solves that problem, allows you to do backups to your project in case your files get corrupted, sync between computers to share your files with your team. It forces you to work in a proper way by committing your work at least once a day, adds documentation to your work, it facilitates team collaboration, blah blah blah. Let's see, I'll use command line or basic. Artists, not technical members, it streamlines the Godot workflow by automating complex tasks such as get LFSS configuration, file locking, so you can anchor points. The whole setup requires 3 minutes. We'll use GitHub integration anchor points so that we can create repositories directly from it, which is faster than doing this on GitHub. Okay. I want to make sure to set this up first. Okay, I guess it's already created then. Let's build from here. Creating a should have a GitHub account. I haven't used it in a while though. Okay, I got that up. Download our anchor point, then click connect the application to exit to GitHub. Download anchor point. Why not? I'll just put it in this folder. Sorry, I didn't notice you. Can hear you faintly in the background.
Hello? Hi.
Hold
I'll be, hold on.
Let me turn that down a little bit. I don't know if I need to go down that low. Go like that. That's probably fine. Okay. Still anchor point. Blah blah blah. I haven't used that many repositories that much, so I mean, if this one's better, I was just using GitHub before, but I wouldn't mind having something that's a little more organized if possible. Even if this person's just being advertising it. Oh wait. Oh no. Hold up. This, okay, never mind. I was just about to complain, but it's fine. It has a free version. I was like, I'm not using something I have to pay money for, am I? I wouldn't want that. I wouldn't want that. Okay, okay. I'll just use Gaggle. Make my life easier. Other. Oh. I mean, I learned it from Anchorpoint's website. The website. Great workspace. Okay, let's get rid of that. I'll delete the thing I don't want, because I don't want this here. I want to see it. Anyways, we got that. Let me read this thing again. Integrations. Said it failed. Unfailed. Gotta try out some stuff. All starts failing on you right away. Not fun. Okay, testing. Okay, it's connected. Create a new project. I always forget which level I want to start on. I'll just do that. Okay. New repo. Open or create group repository that is connected. Open or create. Want to make sure I have this stuff right. I haven't done it in a while. Oh, why did my YouTube close? Oh, weird. Anchor point for processes, metadata, blah blah blah. I know all that. Let's pick new repository, and for the template. Should I change the title to Repos? Let me look at this. Pretty sure I want it like this instead. And I guess I could use it for something else later. Okay, yeah, that looks correcter. That does seem to be correcter. Okay. Initial commit. Oh. I wish it was easier to show all of this at the same time, but it's also really annoying to capture everything without like doxing yourself or something on accident. I guess if you had another monitor, maybe it would be easier. Just screen capture that monitor specifically. I think my friendo is distractimated. Sure. Okay, so let's actually start doing things. So like, what is this folder? Icon SVG. Just that, so I'll just start making stuff. Scripts. Assets. I think a subfolder under it. Let me think. What do I need? Well, actually, Yes. Okay, yeah, that'd probably be better. I wish I could, like, move that to the top of the hierarchy or something. I don't like when it's like that. I get why it is, though. Okay, what other things do I usually need? UI elements? So we have scripts, we have UI elements, what else do we want in there? Scripts, UI elements, humna. How do I go to the latest pushed settings? Or does it not count those things as enough changes to push a file? Maybe not. Anyways, we know we'll need scripts. We can be even more organized as well, of course. We can do gameplay scripts. Organization is always important. You can also do UI scripts. Character art. We will just have a general art tab also. Okay. Would I put UI elements under art? I guess not. That's like what you're using for it. It's not necessarily the UI element itself. Maybe. Well, we'll just leave UI elements without any extra folders for now, just in case I do want to change the positioning of that later. So we have art, we have character art, what else would we have? Level art. Maybe? I don't know if we're gonna need like tile sets or something. Okay. Got a lot of new folders in here. Can I just hit new comment then? Hello. Okay, so yeah, I haven't changed any files properly. That's all. Learning on the fly. We're being educated.
Education on the fry. It's been a crazy day. It's been all over the place, dude.
Push your repository. Or push your suppository. Haha, no, that's not funny. Trying to document my full game creation process, so I'm gonna do this one. So I make sure I know what I'm doing. I was being a bit lazy with the chess one that I did last time. You know that I actually did make a full entire actual game of chess with UI elements, but then then both my artists, you know, they died. They died in a plane crash. One of them was the girl that's talking right now. Are you actively there? What are you doing? I see the curb move, but I think you're still doing stuff. I see some curbage moving over there. The corner. That's some curb in the corner. Dun, 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 na, 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 na. Okay, let's see. Test script. I haven't played with Godot at all, so this will be a process. Let's see. Your first 2D game. There we go. Intended for beginners who fall in. I guess we're gonna go through all of Godot documentation as well. I used Unity for a good long while, but I'm gonna have to actually learn this from the ground up. Legitimately learn it from the ground up. Let me see, where's my web browser here? A random window? Okay. I guess for the sake of using this, I'm going to make this a different window so I can show it to you, the viewers at home. Let's see. Let's see that documentation. That beautiful documentation. I don't know if it's gonna blow up more, but here we go. So yeah, let's start learning how to use Godot, I guess. I did all of the Unity Learn course back in the day to learn that, but get to start all over again. This series builds upon the introduction to Godot, and we'll get you started. Oh no, do I have to go back even further? Hang on, we're going back even further. The series will introduce you to Godot and give you an overview of its features. In the following pages, you'll get answers to questions such as, is Godot? It's Godot. Or, is Godot? Yeah, I'm not going to read the for me part. What can I do with it? You'll then introduce the engine's most essential concepts, run you through the editor's interfaces, and give you tips to make the most of your time and learning. An introduction. Ah, Cassette Beast was in it? I didn't know that. That's cool. It's already cool. I could make Cassette Beast. This article is here to help you to figure out whether Godot might be a good fit for you. We will introduce you some broad features of the engines to give you a feel for what you can achieve with it and answer questions as to what do I need to know to get started. This is by no means an exhaustive overview. We will introduce many more features in this Getting Started series that will be exhaustive. It's a general-purpose 2D, 3D game engine designed to support all sorts of projects. You can use it to create games or applications. You can then release on desktop, mobile, as well as on the web. You can also create console games with it, although you either need strong programming skills or a developer to port the game for you. What can the engine do? What can that engine do? What that engine doing? Like, what was it doing? It was initially developed in-house by the Argentinian game studio. Its development started in 2001, and the engine was rewritten and improved tremendously since its open source release in 2014. Some examples of games created with Godot include Cassette Beast, PVKK, Usagi Shima. As for applications, the open source pixel art drawing program Pixelrama is powered by Godot and is the voxel RPG creator RPG in a box. And so is the voxel RPG creator. Oh, I didn't know that. I was actually thinking about trying to play with RPG in a box before. You can find many more examples in the official showcase. Official showcase. It's very official. Yeah, that looks pretty cool too. It kind of looks like Long Dark style. I guess that would explain the UI. How does it work and look? Godot comes with a fully fledged game editor with integrated tools to answer the most common needs. It includes a code editor, an animation editor, a tile map editor, a shader editor, a debugger, a profiler, and more. That's a lot of things. The team strives to offer a feature-rich game editor, with a consistent user experience. While there is always room for improvement, the user interface keeps getting refined. Seriously though, you like still there? I can't hear you if you're there. Unless you never started. I don't know if you're busy. Of course, if you prefer, you can work with external programs. We officially support importing 3D scenes designed in Blender and maintain plugins to code via C Code and MX for GDS script and C#. We also support Visual Studio for C# on Windows. I do use Visual Script a lot, but programming language. Let's talk about available programming languages. You can code your games in GDS script, a Godot-specific and tightly integrated language with a lightweight syntax, or C#, which is popular in games industry. These are two main scripting languages we support. With the GDE extension technology, you can also write gameplay or high-performance algorithms in C++ or other languages without recompiling the engine. You can use this technology to integrate third-party libraries and other software development kits, SDK, in the engine. Of course, you can also directly add modules and features in the engine, as it's completely free and open source. Did you know that?
No.
Well, now you do know. That's why I'm using it. I didn't know Cassette Beats was made in Godot, though. That's kind of cool. You okay there? Were you busy with someone?
Yeah, it hasn't been my day.
Let's see. Kind of curious to check whether the games were made in Godot. While I'm thinking about it. Brotato? I've heard of that before. Dome Keeper, I've seen a lot of people been playing lately. Buckshot Roulette, I've heard of also. Luckby Landlord. I've definitely heard of a lot of these games recently. Sonic Colors was remade in Godot. I didn't know that. That's actually kind of neat. Cat Calf Manager.
Turn my music down a little, turn you up. Okay. And we're here. We're back.
Hockey. A garden path. A frog refuge. Till then. There's definitely been a good bit of things made, it seems. Not all games I've heard of, but I've heard of some of those games. Curious about what we can learn here. Are you learning anything today?
No.
No?
No. I wish I was. Trust me, boy, I wish I was.
Godot relies on object-oriented programming paradigm. Being comfortable with concepts such as classes and objects will help you code efficiently in it. If you are entirely new to programming, GD's Quest Learn GD Scripts from Zero is free and open source interactive tutorial for absolute beginners to learn to program with Godot's GD script language. It is available as a desktop application or in the browser. We will provide you with more Godot-specific learning resources and learning new features. I am learning from zero here.
Right on. Yeah, I see that you're doing some tech magic stuff.
Not much tech magic. It's just, I have been curious to start trying to use Godot, because it's an open source software where, you know, everyone was having problems with Unity and stuff being all scummy and all that junk, and I don't want to deal with that. I mean, I learned all of my game programming stuff from Unity, and like, sure, I appreciate it. I learned a lot about programming from it in general, and it does luckily carry over to other programming languages. Basic concepts like methods and functions and variables, etc. You know what I'm saying? Maybe you don't know.
I don't understand.
There you go. You get it. You got it perfectly.
I remember you mentioning something about working on game stuff, but I didn't know you were still doing game stuff.
What do you mean by that?
Like, why are you working on a game now?
Because I don't have anything better to do with my life.
I mean, you have your novel to work on.
Well, yeah, but that's not a game. Remember when the game was the game?
The game is still the game. I don't know what you're talking about.
I remember when the game was the game. I mean, I still intend on working on my novel. I just thought I would do this on the days I'm not working on my novel also. And playing games. And I don't have ADHD. Anyway. Our mutual friend wanted to work on a game, so I am complying. I'm like, well, if our mutual friend will be referred to as H from this point on wants to work on a game, then cool. Why not? I will work on a game with H. Apparently Godot script is actually pretty easy though. I don't know. They say right there that it's supposed to be designed to be simpler than C#, and I already think C# is pretty simple. You know what I'm saying?
Right on.
You know what I'm saying? Obviously.
As long as you're happy.
Anyways, I'm probably gonna stream my Digimon again tomorrow, and Wednesday, I guess if you want to stream with me again, then I'll probably work on novel that day. And then on Friday I might do more game stuff, don't know.
Yeah, so the main plan is try, and I say try because today was kind of a mess. Just like that. Come on, man. But the plan is on Mondays, Wednesdays, and Fridays, I'm going to be streaming in the afternoons. I get back by 12 from my class, Mondays, Wednesdays, and Fridays, and then we head home, and we should be home by about, like, to be safe, 1. And then I stream after the fact. But most of the time, I'm probably going to be streaming co-working because I'll be working on projects and stuff.
Understandable.
And taking notes and stuff, so unfortunately I won't be able to stream anything fun.
Huh.
Huh.
Dyslexia font. What is that supposed to be?
Dyslexia font.
That's what an option is. Designed to easier read
Dyslexia
people.
font. And it purposely spells words wrong.
I like how right there it says this does not work with languages like Chinese or Japanese.
No, it would not. I think it mainly works with English.
Wait, how is that dyslexia font? I feel like that would make my dyslexia worse looking at it.
Well, are you able to
They make it
read
like Comic Sans.
Oh. Comic Sans is Comic Sans.
They make it like Sans Undertale talking in Comic Sans. Anyways, they have like a little game, I guess, where you can learn how to do their coding method. So I'm kind of curious to see how it presents itself here. Programming is the process of writing precise instructions that tell a computer how to perform a task. A game's instructions are, for example, moving a character, drawing a life bar, or playing a sound. Yes, I always call it my life bar.
My life bar.
To do any of that, you need to learn a programming language, a specialized language to tell a computer what to do. And it's like I'm back in Unity Learn. I was going to say my Python programming, but the teacher knew less than I did, so... Programming languages are different from natural ones, like English or Spanish. The computer does not think, unlike us. It can't interpret what you tell it. You can tell it something vague, like draw a circle. Which circle? Where? Which color should it be? How big should it be? They give a example with a variable for random angles set to a certain number of degrees. They have a function called shoot, where they shoot the ball and they instantiate it in the ball scene. Add child bullet. Are they shooting a child? The computer needs exact instructions. To draw a filled circle, the computer needs to know exact drawing coordinates, the radius, the thickness, the color you want. The code to do so may look like this. Click the button to run the code example and see the results. We have a draw circle function. They say vector 0, 0 to 60, and the color is aqua. So pretty much they measured the radius of a circle. Interesting. And they just filled it in with the color aqua. In the following lessons, you'll learn how this code works. For now, we want to give you a sense of what computer code looks like. In this example, everything matters. Each parentheses, capital letter, period, and comma. A computer always does exactly what you tell it to. No more, no less. It blindly follows every instruction. Same. No.
Same.
When you program, you're the only one in charge, and you're free to do anything you want. How do you give instructions to a computer? Using prose and plain English, using a programming language, and precise instructions. Wow, I got it right. I'm so smart. You'll learn to code with GDS script. In this course, you'll learn GDS script. That is a programming language I do not know, but it stands for Godot script, which makes sense.
Godot.
Yeah, I say Godot
Godot.
because it's like G-O and then dot. So I just keep wanting to say Godot, but it's supposed to be pronounced Godot. And I'm just like, I don't want to say Godot.
Well, yours is more fun.
Anyways, this is a language by game developers for game developers. You can use it within the Godot game engine to create games and applications. It's language used by games like Dome Keeper, Brotato, and Godot also powers hits like Buckshot Roulette and Slay the Spire 2. I play Slay the Spire 2. That's kind of funny.
Splay.
Yeah, splay.
The Spire.
You gotta splay it. You gotta fillet it and then you splay it. So, I remember a while back, I'm pretty sure Slay the Spire used Unity, but then all the stuff with it happened, so they switched to Godot, so that's kind of funny. I didn't realize how much of it they used or not. Anyway, GDS script is an excellent language to get started with programming because it's specialized. Unlike some other languages, it doesn't have an overwhelming amount of features for you to learn. Most programming languages are similar. Don't be afraid of being locked in. The concepts you learn in your first programming language will apply to all others. I learned C# first, and then I learned Python after. I know a little bit of Java, not too much. I know XML also, and a little bit of HTML. Not that those are the same, but they have some principles that carry over. Anyways, once you learn one, it takes much less time to become productive with the next one. Yeah, there's definitely some things that carry over, for sure, since it's all the same logic. Here's an example of the same code in 3 languages: DDC script, JavaScript, and Python. God, I hate Python and Java. Try to spot the similarities and the differences.
I hate all of it. It's all confusing.
I always think that Python is very sloppy. I think that Java is at least a little neater, but I don't know. It looks like GD, that's not gonna mess me up at all. GD script seems to use abbreviations more, possibly. Like it uses func, like you're calling someone an unk, but they're funky.
Like you! Oh, rude.
I'm old. My hair is whiter than yours.
True. I never thought it'd ever get to that point, but it did. But I've only learned like a couple of very, very basic coding stuff, but only in times where I've had to, and I've usually like looked it up, and people have helped with it. And I did make a very basic coded website once, but that was when I was in high school.
Well, for this one, it's a little funny when I'm looking at it. They're using a take damage function, essentially, and they're like, okay, you that it's going to calculate the amount of damage you took. So when you take damage, it looks at your health and it minuses your health by the amount of damage you took. And then they have an if statement that goes, if your health is equal to or less than 0, then you die. It calls the die function. Or method, rather, but I find it funny how they wrote that. It doesn't look that different, does it? The 3 examples they show use like the same variables and stuff, and as one would know, yeah, they don't. No, they have many similarities. You're right. Most programming languages build upon the same ideas of how to program. As a result, they're mostly similar. It's not to say all languages are the same, though some differ. Some offer unique syntax and require completely different mindsets compared to GD script. However, languages like GD script, Python, JavaScript, C++, C#, and many others build upon similar programming philosophy. This is a course for beginners. If you want to learn to make games or code but don't know where to start, this course should be perfect. We design it for absolute beginners, but if you already know some other languages, it can be a fun way to get started with Godot. That is what I am doing. I'm trying to get started with it, so I know how to use it. Blah 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 blah. Creating games is more accessible than ever. Blah 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 blah. What and how you'll learn. In this free course, you will learn the foundations you need to start coding things like these, an inventory, and a little line. Along the way, we'll teach you some of the mindsets you need as a developer, blah blah blah. Blah 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 blah. Is this Godot for? If you need any time before you bring in questions, blah blah blah. Okay. Try your first code, run your first bit of code, and see the result. Sure, why not? Goals. We prepared a sample for you for this practice. You don't need to change anything. To test code, click the run button below the editor. Is that how they present the code here too? No. It's a little similar, but not the same. Welcome. You completed the practice. Stay and play around or continue. Continue. I get it. I wanna write the stuff. Because I know they're...
Give me stuff to write with. Let me write. Let me do stuff.
Well,
he
like...
wants to do things.
Unity had a very specific way of structuring stuff, like you would create a... you'd create your method and the opposite way. I always get method and function confused for some reason. It's the dyslexia. We'll say it's the dyslexia.
If you laugh at me, you're making fun of a disabled person.
There you go. That's the mindset you're supposed to have.
Yeah.
Errors help you write and correct programs because they show you what is wrong in your programs. A code error looks like this. It's a message that tells you some bit of your code doesn't work. The function move already exists in this class. Oh yeah, and classes are different too. I'm very bad with the vocabulary, even if I know what things do. Always.
I am also really bad with vocabulary. Like, I've written everything I've ever learned so far in university down on paper, but I always still forget.
An
all
error
the time,
translator.
always.
I mean, that's a helpful way to learn for what they're showing here. That's an interesting way to do it. Error messages are designed on purpose by fellow programmers who came before you. They anticipated you might have specific issues and wanted to help you fix them. You shouldn't think of errors as failures. They're like mentors, helping you from the past. Importantly, errors won't break your computer, at least not with GD script, because it's pretty safe language. Ultimately, you want to fix all the errors in your programming. Understanding what is causing the errors, I can't speak today, with the help of error messages is key to fixing them. They're there to help. The error messages are always bad. Code is incorrect and calls an error when you try to run it. This code defines an empty function named "this code is wrong." Okay, to work the function should use the return keyword, but this keyword is currently inside a comment which ignores... Wait, is there... Okay, their comments are just one hashtag. That's nice to know. Remove the comment to make the code valid. This code not be removed by spacing. Okay, well, let's see first. We get the error message. Then we remove the comment, and boom. Okay, it looks like their coding might be a bit more basic with how to structure it also, so I'm kind of hoping they let me add in pull-down tabs. I always like pull-down tabs to categorize things. We stand on the shoulders of giants. As programmers, we rely on a lot of code created by others before us. We literally do copy and paste homework, except that's what you're supposed to do. You'll use a lot of existing code. When coding, you always use a lot of code from developers who came before you. In a moment, you'll write your first code. You'll use functions created by Godot developers. A function is a list of instructions with an exact name. We can tell the computer to execute all the instructions in a sequence with that name. Calling functions. When you tell the computer to execute a function, we say you call the function. To call a function, you write its exact name followed by an open and close parenthesis. To call the function named show.
Walks into the function.
It would be more like function Lanfi run. Anyway. You would write show, parentheses, in Godot, calling show makes something visible, like a character or an item. The complementary hide function hides the entity. Once an entity is visible, calling show again doesn't have any effect. Similarly, once you hide something, calling hide again doesn't change anything. Click the run button on any example below to execute the code listing. So we have a function that says run, and then it goes to hide. So we just have the little sprite animation that they have idling. It disappears. In the code listing above, we write a function called hide and a new function named run to execute the code. Creating a new function is necessary to execute instructions in GD script. Can you tell me more about the run function? Unlike in some other interns, we must write our code inside of custom functions. You learn what functions are and how they work in great detail, blah blah blah. I know what functions are. I'm pretty good with those. So they need to write the keyword func, the function's name in parenthesis, and a color, and a colon. So you do func to define the method, And then the function name would be the run with the closed parentheses, and then you write a colon and it defines a function named run. Then you go to the next line to write the function's body. That's the instructions of the function. And then you can recall the function in a different function, ideally. Notice how each instruction starts with a leading tab character. Computer uses that to know which lines are part of the function. Throughout the course, you'll see many functions called run. Those functions we created to give you an interactive example. We use parentheses to call functions because you can give function arguments inside the parentheses when calling it. Here's a sprite standing straight. If we call the rotate 0.3 function, the character sprite turns by a 0.3 radians. Boom. Rotated. Get rotated. It does it on the x-axis as well. Or is it the y-axis? Do I know my x and y's? It's like your right and some lefts. Oh no, my headphones are running out of battery.
Oh my god! Plug them in! Hello, Kasu. Welcome back. How you doing? That's a great question. Lanfi, how are you doing?
Wait, what?
How are you doing today, Lanfi?
Why wouldn't you say how you're doing? You're asking how me?
I am having a crazy, wacky, weirdly bad day. How about yourself?
You know, I'm feeling like by calling the rotate function without any argument would result in an error. And without an argument, Godot doesn't know by how much you intend to rotate the sprite. You know what I'm saying?
Soka. Soka.
I could say, Genki.
Genki desu ka? Absolutely horrible.
I could go like, Atashi wa sugoi desu. I'm awesome. I'm awesome. In the feminine way. Because I said Atashi. Even though that Watashi is technically feminine also, but...
I'm decent aside from school starting again, and my smart ass is gonna have to write my philosophy studies this year. GG. GG is easy. Good luck. It's all over. It all goes downhill after that. Or uphill, depending on who you are. I
Or...
feel like rotating a chrome in mine. Just do it.
Or don't worry about memorizing what arguments each function requires or accepts. As a programmer, the documentation will always be close by for you to refer to. That's a pretty nice way to put that. I feel like some teachers are too anal about memorization stuff, when in reality, even if you have like a programmer job, you usually have right in front of you the documents that tell you how to write it for a lot of the stuff. Like, why would I want to remember how like degrees and radians all function, or like what pi I need to go to, etc.
Yeah, Lanfi is learning coding stuff for games. That's what he's doing.
Numbers. I say numbers to her.
Number go brr.
I like how they say. Notice how you use a dot. We use a dot like this to represent the decimal numbers. Yeah, you can just say period. You don't need to say dot. Can't use commas as they have a different purpose in coding. 0.3 is an angle in radians. In daily life, we've used some measuring angles in degrees. The radian is another scale commonly used in video games and math. You can convert radians into degrees by multiplying them by 180 and dividing them by pi. An angle of pi radians corresponds to 180 degrees in 2 times pi is a full 360 turn. How do radians
360
work
must
exactly? Radians are a way to measure angles based on the radians of a circle. The radius of a circle. To get angle on radians, you take the circle's radius and wrap it around the circle. That angle is 1 radian. Because you are wrapping the radius 1 time around the circle, because the parameter of a circle is 2 times pi times radius, a full turn 360 corresponds to 2 times pi radians. You need to wrap the radius of a circle 2 times pi times around the circle to make a full circle. You get all that? You get all that? You hear that?
Absolutely not. But yes, please continue. That's how college works, right? You guys get that? Have any questions? Okay, cool. And no one answered the question because they just don't.
I have seen that happen several times. Especially when I'm like in when I was doing college stuff, whenever you're doing the online lectures. Everyone would just be sitting there and staring at the screen, and then the teacher stares back at you. It's just like, any questions?
Yeah.
They wait like 3 minutes and then goes, okay, great.
Yeah. I had that quite a lot happen in my digital courses.
It reminded
and
me
even
of like...
in my seat in seat classes, they'll be like, any questions? Look around. Everyone's just staring. Brain dead. He's like, okay, awesome.
Drooling.
But everyone has the questions after the lecture is over, though.
Okay, another example with the move local x function. You can move the character to its left and right. The function takes 1 argument, a number of pixels to offset the entity. Anyway, when teachers do that, it always makes me think of the children's show, you know, where the person is just like, can you find the missing map? And the map's like right next to you. And they wait like a minute or something, and then they go, great, you found it!
Great, good job!
And then the child claps. They're just like, babagoo.
Yeah.
Amazing. Okay, move local Y, makes the character move up and down, makes sense. Boom. So scary. They move slightly into the bottom right corner. Uh-oh, I made him do it again. And I made him do it again. Oh no. Y local 20 moves the character down. With positive values 20, the code above moves the robot to the right and down. This is probably different than what you studied at school in math classes. The horizontal axis points to the right, like here. But the vertical axis points up. In video games and generally in 2D computer graphics, the vertical axis points down instead, so whenever you move something on the y-axis with a positive value, it'll move down. That's weird. I haven't really done much 2D stuff though, so I guess that makes sense. How do you call a function? What is the syntax you use to call a function in general? I feel like they wrote this question strangely. You write a value, like a number, followed by an opening and closing parenthesis. I mean, I would say that, but I feel like they want me to... No. That's weird. I don't know. I don't really get how they're asking that question. It's like you would write func, and then you would write the variable for it. and then you'd write the function you're creating. Well, I guess you could just do func, and you could do like run, and then the parentheses, and then the colon. I thought that's what they wanted. Anyway, this robot's invisible. Call a function to bring it back. Practice. Okay, that was pretty simple. It's like toddler programming. Make the robot upright. The robot was turned by negative 0.5 radians. You need to make it upright by calling the rotate function. Get rotated. Please call the rotate inside the run function on line 2 and keep the tab character at the start of the line. Computer needs to understand your code. Rotate. Character is up right now. Get rotated. I'm drawing a rectangle. My headphones are running out of juice. You know what? I got earbuds. I got earbuds.
Genius.
So I can't hear you right now, but just to get this part out of the way, for when you weren't here, I was writing some of my design document and computer programming or game design projects in this case. It's always good to keep a lot of documentation. I want to make sure I do that properly. So I have a whole design document. Goes over the inspirations for the game itself, concept art. I want to store programming there and then update when I had made a new version of the program, if ever. As well as show like screenshots from other games that I'm using for like UI designs or general ideas for the gameplay. Worker H also has been writing some of their own inspirations in there as well. Sounds so weird when I'm listening through earbuds. But I'll have my other headphones, the good ones, charging. Meet the turtle. We present you the turtle. We created the turtle to teach you how to call functions. The turtle is a little machine that moves forward, turns, and draws lines along its path. To make it draw, you give it a list of instructions. On each code line, you call one specific function. We prepared several functions for you. Move forward, pixels. Makes the turtle move forward given distance in pixels. Turn right makes the turtle turn clockwise by a precise amount of degrees. And then turn left works the same as the turn right degrees. Excuse me. Except the turtle turns clockwise, counterclockwise. Okay. You'll use these functions the same way you used rotate. The turtle draws a white line as it moves. We'll use this line to draw shapes. For example, to move the turtle 200 pixels, you would write move forward 200. Boom. And move forward 200. That's kind of neat. That's a neat way to teach it. Ironically, Python has a thing like this too, where you create a little gambling thing with turtles. You make different colored turtles. It's a pretty common teaching program where you write that up and you have like a yellow, blue, green turtle or something. Yeah, you place bets and it tells you who won.
Ninja Turtle.
Not Ninja Turtle. Gambling turtles.
Teenage Mutant Gambling Turtles.
Turtles in a wheelchair.
Turtles in immense debt.
Turtle power. The functions turn left and turn right work the same. To turn 45 degrees to the right, you would right. Turn right. That's a lot of rights in a row. If we call...
Turn right, then turn right. Now
Yeah.
go right.
To write out someone turning right, you have to write turn right. If we call turn right, the turtle turns 45 degrees to the right before moving on to the next instruction. So we have the function presented for run, because we're just running that program. We have move forward 80. We got turn right 45, move forward 80, turn left 45, and then move forward 80. Boom, boom, boom. Made a little line. And every time it turns, it creates a different point. Interesting. Using these instructions, we can make any two-dimensional shape we like to try and understand the example below, and the next try to understand the example below. In the next practice, we'll use the functions we saw above to draw a corner, then a rectangle like this one. They made a rectangle. That's a lot of turning. And the function called below, which part is the argument? The argument is the value. A function arguments are all the values inside the parentheses. In this case, there's only one. But there can be multiple separated by commas. In this case, move forward is the function's name, and 30 is the argument. This function call will make a turtle move by 30 pixels. See, I didn't remember that it was called an argument. Didn't remember that. Bad with vocabulary. So bad. Turtle uses code made specifically for this app. Turtle is a little learning tool. A little learning turtle. A custom made for this course. Are you just learning with me now? Or are you just listening? I don't know.
I've been taking notes. Not to what you're saying, though. Different kind of notes.
Taking
You're like,
notes?
oh yes, indeed. I am learning with you.
Why are you doing it like that? Why are you doing it with a little accent? Don't be surprised if writing code like turn left inside of the Godot editor doesn't work, and don't worry. Once you've learned the foundations, you'll see they make it faster and easier to learn Godot functions. Let's move on to practice. You like to play with the turtle functions to draw shapes. That's drawing a corner. In this practice, we'll tell the turtle to draw a corner. The corner is made up of two lines that are 200 pixels long. The lines are connected at each end by 90 degrees or a right angle. The forward and turn right functions to the right draw a corner, but they're missing some arguments. Add the missing arguments to the so the turtle moves forward 200 pixels. Turns 90 degrees. We have the first argument. Turtle moves. Boom. Well done. I'm so good at this. I know how to write basic things. Add the correct arguments to the function. Move forward and turn right to draw a rectangle with a width of 200 pixels and a height of 120 pixels. Draw a bigger rectangle. Draw a rectangle of 200 by 120.
Wow, sleepy.
So wait. I want to go move, return. Okay. And you just turn 90 degrees each time, right? Okay. Write out calls to the functions. Move forward. Turn right to draw a rectangle with a width of 20 pixels and a height of 2060. We wrote the first two lines for you. Okay, so it moves forward 2020, it turns. Then we need to do move forward and make sure to call it accurately and correctly. Except this time we're doing 260. Except we can do the basic principles we already applied to the last one. Oops.
You broke something.
No, I didn't. You did.
Yes, you did.
Oh.
Can't turn that on me. I'm ahead of you.
Like, I already finished making the game. Cassette beats, I did that. Okay, I did the lesson. I wonder how fast they intend you to learn this. I mean, it is showing me the basic ways the code works. I do understand it fine enough, just from doing normal coding before. Functions are named sequences of instructions. Functions are sequences of instructions we give a name. We call that name an identifier. Using the identifier, we can get computer to execute all the instructions inside the functions as many times as we need. This is what a function call does. If there is any code you need to run multiple times, you can put it inside a function and give it a name. The instructions inside a function can be any code you want, and they will all run every time you call the function. Here's the example move and rotate function that moves the turtle forward and then turns it 90. Boom. The move and rotate function consists of two instructions, each on a separate line. Both of these instructions call another familiar function. You could write another function that calls move and rotate 4 times to draw a square, the length 200 pixels. Boom, 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 boom.
A boom!
I wonder if it does that logic automatically, or if this is just serving the example, because I feel like you would have to define, like, how long that takes between them. Like with enumeration or anything like that. Every time we move and rotate two functions, blah blah blah, sequence is an example. May not feel super useful. Here's a more useful, realistic one. To draw any square. The following function uses parameters, which we'll explore in the next lesson. Drag the slider to change the square size. Oh, I understand. They make the size of the square be a float. And they make this change the float's value as the variable. So this acts as the variable size. That's a clever way to do it, I suppose. How to define your own functions. Let's break down how you define a function. A function definition starts with func. We got the func. That func, your func. Followed by a space. The function's name, parentheses, and a colon. Okay. Why do we use functions?
Why do we exist?
To run multiple instructions in one go. Oh. Do you want me to say all of them? Because fine, I'll just say all of them. Stupid quiz. Names in code have rules. Function identifiers cannot contain spaces. In general, names in programming languages cannot contain spaces. A computer uses spaces to detect separation between different keywords and identifiers. Instead of spaces, GD script, we use underscores. Most programming languages use underscores, it's pretty common. You saw this already with functions like move forward and move local. This is the convention we follow in GD script. There's another convention programmers use in some other programming languages. This is also true too. Sometimes they do the lowercase capital. Instead of using underscores, they start words with capital letters, except for the first one. With that convention, you would write function names like move with lowercase m, and then forward has an uppercase f. Identifiers also have to start with a letter or an underscore. You can't begin with a number, but you can use numbers after the first character. Which of the following names are valid function names? Valid. You're so valid. Oh my god. Instantly moving the turtle to a different position. In order to draw multiple squares in different positions, we introduced a function for our turtle to use. The jump function picks up the turtle and places it relative to where it is. So calling jump minus 150 moves the turtle 100 pixels to the left and 50 pixels down without drawing any lines. Boom, boom, boom. That looks that's a funny animation to use for it. Boom, boom, boom. Okay, draw squares. Boom. I'm going boom, boom, boom. Code a function named draw square. To draw one square of a length 200 pixels, the function should take no parameters. In the following practice, you'll use the draw square function to draw multiple squares by calling your own function. Okay. Funk. We got the funk. I got the funk. That funk-a-funk. Move forward. 200. 200. It doesn't specify, so... Does it actually want me to do the tab myself? Trying to teach me? Look at them trying to teach me things. Why did I double up that? You go one side, two side. One, two, three, four. And I don't need the last one. Incident. Oh, wait. Forgot the stupid colon thing. Forgot the stupid colon. Well, that's why we're learning. That's why we're learning. Okay, what are we doing
Learning
now? Are we? It's more like I'm speaking, learning words, and you're probably doing something else, I see. Them learning words. What are you learning? Are you drawing your arts for art projects?
I am arting so good.
Arting so hard, so stiff. Okay, you have function to draw 1 square. Use it to draw 3 squares. Dun dun.
Always the law and order creeping up.
You just call the function, all 3 squares will overlap. You can't, like, call it inside of it though, right? Like, I can't call draw square inside of draw square, can I? Cause that'd make a bunch of things. Oh wait, it does say, oh yeah, and so specifically create one that's called that. Oops, I just can't read. They did make a separate one for it. I was talking about, why don't they have that? And then it's like, oh, they do have that. Okay, well then I would just want to do
So,
Did I write it wrong? Oh wait, yeah I did. I was like, I thought I was correct. Oh wait, I did it again. I know how to spell. No brother. On my hyper specific.
no brother out there.
Draw squares. Okay. That took a little kerfuddling, but we did it. It was easy. It was baby. Very baby. We're on lesson 6 out of 27. Which, I mean, not bad. In the previous lesson, you created a function to draw a square on a fixed size. The function is a bit limiting. Instead, it would be much better if we had a function to draw a square of any size. Or better, any kind of rectangle. A square, a specific kind of rectangle. In the previous lesson, you used rotate function and gave it an argument. Just like rotate, we can also give our functions parameters. Parameters act as placeholders in functions code. Wait, do they use parameters instead of variables? They work like blank spaces that get filled in each time someone calls your function. When you write a function with parameters, you create a flexible template that you can work with at different values each time you use it. Let's see how the rotate function is defined and uses a parameter. Okay, so we know rotate equals its rotation equals rotation plus radians. We're now focused on the first line of the function definition, func rotate radians. The word radians is the function's parameter. It's a placeholder that gets replaced with the actual value when you call the function. When you call the function with rotates, the computer replaces the name radians with the function. 0.5. Each time you call the function, the replacement happens again. If you call rotate 1.0, becomes 1.2. Same thing. Parameters can be filled with a number, text, or anything else. In this lesson, we'll use only numbers as we have yet to learn about other value types. Why? Why?
What?
I want to use variables. Number. Okay, so okay, you're just explaining those a little bit. Here's an example with a function to draw any square. The parameter size is a placeholder. Use the slider to change the value. When you click the button, the app calls draw square. Placeholder gets replaced with the value of the drawing squares of different sizes. This is a thing we already use pretty much. Baby square. What is the correct syntax for function definition? Oh wait. Keep missing the colon, just like when I missed the semicolon in C#. Function can have multiple parameters. You can use as many placeholders as you need. To add multiple parameters, write a comment between each placeholder name. For example, function move x, y has two placeholders, the x and y. Each one gets replaced with its own value when you call the function. This is when we get to do the algebra portion of the programming. You like algebra? Algebra?
No, I was always bad at it.
But if x equals 100 and y equals 30, then what is z?
Zebra.
It's the correct syntax to define a function with multiple parameters. That one didn't have commas. Now it's your turn to create a function with multiple parameters. Isn't that cool, kids? No, it's not cool. It's lame. I suppose my title was correct though, making a video game from the ground up. And by the ground up, I mean learning how to code, right?
Of like literally, we're in the 101s.
Luckily, we're probably doing this relatively quickly. Maybe. I'm going a little slow because I'm actually reading it. Me actually learning, I know. But a lot of this is just review, in a way. I will call your function twice with different values, 240 and 120. Your task is to add parameters named length. This creates a placeholder. Okay. That's pretty straightforward. Making triangles. This will help me get back into the mindset for programming though, so that's nice. I'll be doing a 2D game. Like a Vampire Survivor kind of thing, like we had talked about before in the past.
I was gonna say, are you gonna make it a mobile game or something?
Probably. Right now, though, the idea is to make a game that functions. We want to make a prototype, and employee H will be making the art and animation. Is at least the idea. We'll see how that goes. I don't know if I'm gonna have him make like tile sets or something. We'll have to talk about that later. Anon. Don't know how hard we want to go, but ideally the idea is make one level to be able to showcase our gameplay, our stats, etc. And then we can call that in like an actual alpha build. Now let's make the draw corner function even more flexible. We'll add a second placeholder so the angle can also vary. So now we want angle. Our task is to add the angle parameter after length. Remember to separate the two placeholders with a comma. I think this was one thing that I didn't really know that well when I was doing C# stuff. I feel like Unity didn't teach you about parameters well enough. It's like I understood it fine, but having the brief rundown is always nice. Makes you make things less sloppy. Time to write a complete function from scratch. We'll make a function that draws squares of any size. I'll call your function with different sizes. 200, 100. Write a function named drawSquare.
My function? Damn.
With parameter called length. I'm gonna show you my full length right now.
Lanfi walks into the function and says, "Hey, do you know how to code so that you can make video games?" No. I can.
Well, I could right now on Unity, I guess, but it wouldn't be a good game, but I could make a game. Like my weird meat walking simulator. Walking in meat. I would like to be able to do like a game jam or something one day though. I think that would be fun. It'd be nice to learn enough to be able to do that competently and quickly. Some people do that, well, I mean game jam is usually a month long, so yeah, of course they do. They do that stuff quickly. They do it quick. They do it darn quick. Okay, we got move forward. Probably call it like turn R or something. It sounds like something else, maybe. I don't know. Oh, I did it again. Every time. Oh, I did it again. I always make dumb little... Oh, wait. I forgot we're doing a square, not a corner. Oops.
You're already messing with stuff?
I mean, I've been messing with stuff, but it's just a teaching program, if that's what you mean.
Yeah, I thought you were just reading up on it, but not messing with anything.
Yeah, no, I wrote something incorrectly is all that I was saying for that. Wait, why did it jump? Oh wait, no. No, wait, go back. I accidentally deleted it. Now I have to write it all over again.
You were the chosen one!
With an extra girthy length. Maybe not that. Okay.
You were supposed to start this with, not join them. You underestimate my power. Don't do it, Anakin. I have the high ground.
You having fun over there?
I'm in my own head while I'm taking notes.
Wish you wouldn't indent automatically. Oh well. I don't know why they haven't jumped, but okay. Let's create a function to draw rectangles with any length and height. We got length and height. Function needs two parameters, length and height. Already did that. When the app calls for your function, the first number replaces length. Second replaces height. So we want length, height. Okay, pretty straightforward. Lesson complete. Dun, 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 dun. In this lesson, let's take a first look at variables.
Level up.
Finally, variables. In games, you need to keep track of many variables that change over time. The player's score, every character or enemy's health, the last checkpoint. Naruto, the last checkpoint. We call those values variables. Variables are labels you use to keep track of values that vary over time. Here's an example of a variable tracking a character or monster's health. Variable health equals 100. The line above defines a new variable named health and assigns it a starting value of 100. Function parameters, which you saw in previous lesson, are another example of variables. In this lesson, we start using variables built into Godot. You'll be good though. No, it's Godot. They're a particular kind called member variables. I got a member right here for you. Get rotated. Member variables are values attached to a game entity. They're useful properties like position, rotation, and scale of a character. In the previous lesson, we saw how we could use rotate function to rotate our character. And you can keep pressing it to rotate them fully. Boom, 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 boom. Get rotated. Rotato, my rotato.
What are you gonna do when I rotate you, huh? What are you gonna do now?
The function increases or decreases the value of the entity's rotation member variable. Say we want to reset the rotation to 0 and make the character upright. Using the rotate function can prove difficult. You need to know the character's exact current angle to cancel it out. It's much easier to use a member variable rather than the function. The following code assigns the value 0 to a character's rotation, resetting its angle and making it upright. Boom. Notice how we use the equal sign to change the value of a variable. What's a variable? A label you use to keep track of a value that can change, a function that varies over time, a decimal number. A label you use. Accessing subvariables with the dot. In video games, you'll see many member variables have subvariables. For example, position. The position we mentioned has 2 coordinates, x and y. It's the same for scale. It has x and y subvariables. They respectively control the horizontal and vertical axis of the game entity. To access those xy subcomponents, you add a dot after the variable name. The code below places the entity at 200 pixels on the x-axis and 250 pixels on the y-axis. Notice how we use the equal sign to assign the values on the right to subvariables on the left. Sometimes you use equal. I don't know if they have equal in the scripting format though. It's common in other one, but that was more for like if statements and stuff. Unlike in math and computer programming, the equal sign does not mean is equal to. Instead, it means assign the result of the expression on the right to the variable on the left. We assign values so often in code, we prefer to reserve the equal sign for that. In games, the y-axis is positive, going down. Note that in games, assuming your character's position starts at 0, 0, the code above moves the entity 200 pixels to the right and 250 pixels down. In math, the y-axis is generally positive, going up by convention. The convention is the opposite in video games. In many computer applications, the y-axis positive is going down. Why does the y-axis point downwards? On a computer, the position 0, 0 happens to be corresponding to the top left of your computer screen. It then makes sense for the coordinates to be positive when going toward the bottom right corner. This leads to another question: why is the position 0, 0 at the top left screen? This is due to computer TV displays history. They would calculate the display pixels starting from the top left corner and moving towards the bottom right. Let's look at one last example before moving on to practice. The following code makes the character 1.5 times its starting size. Boom. Make it bigger. Make them even bigger. The variables often hold subvalues, like the position has 2 variables, x and y. How would you access the x, for example?
By pressing it.
No. We're at a dot. Not a period, it's a dot.
Oh.
My brother's being really loud outside. In the next lesson, we'll create your own variables and do operations on them to add or...
It's a brain refresher.
For a lot of it. Like I said, I haven't done GD script before. I know other programming languages, so a lot of that carries over, but I haven't worked with this programming language. So it's more me learning what specific words they use. Like, for example, if Python uses def to define a function, it uses def. This one uses func, func, not fu, just func. You're going like, oh, YouTube is going to go no. Don't say fu. Just like it's func, it's the function variable. The function function. I mean, it would be the function in this case, but that's fine. The function is the function. Now, can you call the method to my function, if you know what I'm saying? Anyway, draw a rectangle. At the position 120x, 100y, 200, 120. Okay, funk. You got funk. That funky hunk. Big stretch. Wait, what was the thing called? It's position. Position is what it is. Okay. This means you should position the first square at 100. I guess I just don't need to do that. I have to change the X position. $100 each time. What was it? It's like 500, 300, 500. Okay, defining your own variables. So let's go through. Imagine that you need to track the player's health in your game. So this would be relevant to me. we are going to have health in a game. They may start with 5 health points. When taking a hit, the health should go down to 4. After another hit, it should be 3, and so on. To keep track of that, you create a variable named health, to which you add and subtract points. The example below introduces the print function, which outputs its argument to the output box on the left. Click the run button to instantly run the entire function, and click the step button to execute lines one by one. The debugger panel at the bottom shows the current value of the health variable. So you run. Okay, they're just showing it one at a time. That's a neat way to do it. After executing the first 2 lines, you'll have health variable storing a value of 4. Below, we'll break down how you define the new values and explain the print function. Defining variable. To use a variable, you must first define it so the computer registers its name. To do so, you start a line of code with the var keyword, followed by your desired variable name. This one's pretty similar to normal stuff. Like func stands for function, var stands for variable. Variables are case sensitive, which means health and health are technically different variables. One has capital H and one has lowercase. Be careful to use the same capitalization wherever you refer to the same variable, or you could be reading or writing it to a different variable. The following line defines a health variable pointing to no value. You can think of it as creating a product label you have yet to stick onto something. Like with functions, a member variable's name must be unique inside a given code file. Creating 2 variables next to each other with the same name will cause an error. To use a variable, you want to assign it a starting value. You can do so using the equal sign. This code assigns the value 100 to a new variable named health. So variable health equal 100. After defining your variable, you can access it by writing the variable's name. Boom. I wonder if the run function is supposed to be like their void function. That must be how it is. Like the start function. Must be the same difference. Unless it isn't. The code above will display the number 100. The sum output window. Notice we don't use the var keyword anymore, as we only need it to define the variable. Also, once you define a variable, you can change its value anytime with the equal sign. Boom. So we started with 100. Health then goes to that, and you print it. The print function is generally the first function you learn in academic programming courses. True, it is. It prints the message or value. You give it to some output window, often a black window with plain white text. Programmers often use print to quickly check the value of their variables when their game runs. In the app, we made a special output window that captures calls to print and displays a card to make it friendlier for you. Hey there. Here, the verb print means to send information to display on the screen. The function prints things on the computer display. It does not relate to printers. Variables are like labels, and labels are like onions. As we hinted in GD script, variables work a bit like labels. Assigning a value to a variable is like taking your label and sticking it onto some item. like a supermarket, has a database of product labels. The computer keeps a list of all variables in your crude. Given the variable name, the computer can look up the attached value. It has an important consequence. In GD script, you can stick that label to any other value. Dun dun. The above code is taking a label from the appropriate item and sticking it to the wrong thing. At line 2, the health variable looks at the holds a number. From line 3, it holds text. Computer will let you do that. The code's syntax and grammar are correct, but it's not good. The variable name should describe the value they contain, so a health variable with the text value will confuse your future self and other coders. It can also cause errors in your game. Later on, we'll see how to avoid the issues with variable types. For now, let's practice creating variables. I created a variable. Basic thing. Always do. Create variables all the time. I'm creating variables all the time. It's great. I killed it.
I think I'll be right back.
Okay. I continue to learn. Or relearn. Okay, I know that stuff. We'll see how to manage this in the future using conditions. Their opponent's health could increase instead of if a player picks up an item that heals them or use them as a healing item. Boom. Oh my god, it's so... The health can go beyond 100. Also, once more, the short line health plus equal amount is equivalent to the longer form health equal plus amount. Assuming the amount is a positive number, which of these would increase the health of the robot? Oh, wait. Yeah, it does. Making sure it functions like that. Health can decrease. Okay. In our game, the main character has a certain amount of health. When it gets hit, the health should go down by a varying amount of damage. Add to the take damage function so it subtracts the amount to the predefined health variable. Oh, wait. Oh, wait. Okay, so... It's time to heal the robot up to full health. Write a heal function that takes the amount as a parameter. Okay, and then we want func heal. I think this is a nice way to teach this kind of thing. It's pretty fun. Pretty fun way to do it, I think. set that to 50 also. Oh, wait, I always do it. Oh, it is good practice though. Helping me learns the learny stuff. Yeah, let us continue. I'd say I feel like I'm going through these pretty quick. The game loop. I'm curious how they will teach other things in this very basic course, but it is helping me understand the syntax and the words that Godot uses. Take the process function. Process function gets its name because it does calculations or continuous actions. Okay, so it's just processing. So that'd be like the running things. They're just continuously doing what is inside of them. It's like a juice factory that processes juice bottles. The bottles are always moving along the conveyor belts, while a different machine operates on them. It's similar in Godot, but this function can run hundreds of times a second.
So I ended streaming very early. Because I'm really tired.
Function won't do anything until we add something to it. You might notice the underscore in front of the function name. This is the convention programmers use to coordinate work. It can only make sense once you have experience coding in Godot. Here now, all you need to know is that if the function exists in your code and it is called precisely process, then Godot will automatically run it in every frame. When Godot draws on the screen, we call that a frame.
And I think I'm gonna go take a nap.
You telling me that? You sound very far away.
Yeah, I ended stream early because I have been falling asleep on my desk while trying to.
Okay, that's fine.
I think
Go nap if you
my
need
body
to.
told me I need to take a nap. Yeah.
I will erase your name from my title.
Like, how dare you leave me so early? Be gone! I will be streaming again on Wednesday, but I know you said you'll be busy then, right?
Okay. Feel free to
Okay.
message as you feel like. I'm going to learn.
Tell me how that learning goes and tell me, what you're able to get done.
Just being... When you click the button, set process true, you activate processing on the robot. From there, every frame Godot runs the process function. Since we wrote a rotate instruction, Godot is rotating the character by 0.5 radians many times a second. So it's just constantly spinning. How often does the process function run? Multiple times a second. Runs at every frame. So it'd be like, I'd run at 60 frames a second, let's say. Yeah, that would be a lot of stuff. In practice, you'll learn how to use the process function to rotate and move a character yourself. Let's do it. Make the robot rotate slowly by adding the process function. Adding to it. Rotation speed is about okay. We rotated. Get rotated. Void rotate. Wait, they still use void? Huh. I wonder if later if they show the proper code lines so you can actually figure it out easier. I still think it's a good way to help me get used to how the syntax functions, at least. Make the robot move in a large circle slowly by rotating it and simultaneously moving it along its x direction. To do this, add the rotate and move local x. Use a rotation speed of 0.05 and move 5. We've seen how we use our character's process function to make a move continuously. But it's not just our character has that. It's not just our character that has a process function. Almost everything in the game has a process function. Dozens of times per second, Godot runs every process function in the game to update the game world. After that, it displays an image of the game world on the screen. We call that image a frame. Godot then moves on to calculating the next frame. As this happens a dozen times per second, you get an illusion of movement. This is similar to how traditional animation works. You may have heard frames per second, or FPS for short. Games often run at 60 frames per second. It means that everything in the game updates 60 times each second. The number varies while playing, depending on the game and the device it runs on. A powerful computer, you may get frame rates in the hundreds or thousands of frames per second. Okay, what parameter does the process function take? Delta. Frames take varying amounts of time to calculate, depending on the game computer and what game engine needs to calculate. Frames take more time or less time to display. There will always be small variations from frame to frame. That is why the process function receives delta parameter. Delta represents a time difference. It's the time it took Godot to complete the previous frame in seconds. We can use it to make sure the game runs at the same speed on all computers. It is because different computers have different processing power. So a fast computer will have more frames per second than a slow computer. If we ignore delta, the movement speed will vary. Depending on the computer, delta helps to make the computer consistent for everyone. Oh. I don't like when they do all multiplying by delta. The delta you get in process is a different time in seconds. It will generally be a teeny decimal. To apply delta, you need to multiply your speed values by it. When multiplying by delta, make the motion time rather than frame dependent. Time dependent rather than frame dependent. That's essentially to make your game consistent and fair. Okay. Huh. Interesting. That would make sense. At the top of the lesson we made the robot rotate a fixed amount every frame. We now multiply the argument by a very small delta value that is much smaller. Makes the robot turn at a consistent speed over time. However, multiplying by a number below 1 like delta makes the result smaller. To compensate for that and make the robot turn fast enough, we use a larger number than before. Those numbers have two different units. There's an angle in radians, while we use angular speed in radians per second. When you multiply any angular speed by a time delta, it gives you an angle. And don't worry if it's a little confusing for now, it'll eventually click as you deal with speed, acceleration, and motion in your games. You like learning physics, kid? Why the time between frames matters. The time it takes to display a new frame varies. If you don't take the time into account in your code, your game will have gameplay issues and bugs. Godot provides that time to the process function through delta parameter. In the example below, the robot moves using delta as a result. It moves at a fixed speed. The bottom robot moves over a constant distance every frame. Without taking delta into account, it will move faster or slower depending on slower than the top robot on your computer. Multiplying time-sensitive values by delta makes them time-dependent rather than frame-dependent. Thanks to that, we get a reliable movement over time. Frame times vary from computer to computer and from frame to frame during the gameplay. Because frame times vary, if delta is not used, movement speed will differ for each player, making the game inconsistent and messy. What does this mean? Rotation speed times delta? Multiplying the rotation speed by delta. I don't know why they'd ask that. Okay, so at the moment the rotation of the robot is frame dependent. Add delta to make the rotation speed time dependent. The robot should rotate 2 radians per second. Had to calculate that one, huh? Had to go over that one in its head. Like, I don't know, you do it right? Let's practice. Make the robot move in a smooth circle using delta. Okay. Rotate 2 radians per second. So wait, am I still using move forward? Didn't tell me to use it. Doesn't say it in here, does it? No. Yeah, silly times delta. We. Take a look at this example. Function, process, rotate. In the above example, what does the number 4 mean? Okay. We've seen different functions using names to communicate with the developer. Labeling value makes coding easier. Angular speed variable. I was like, but technically, when you multiply it, that's the actual angular. I guess they don't want to do technicalities. Here we use angular speed. Script-wide variable in both process function and the step. We can also define variables inside of functions. We align the variable assignment by indenting to make it a part of the function body. Make sure to create the variable before using it. If we define a variable inside a function, only the function can use it. Okay, so only angular speed can be used there. result in an error. Here's what the error might look like. Where can we define variables? Grouping values that control characters' behave, grouping them in ways that allows us to easily change them. Controls movement, horizontal speed, jump strength, gravity, variables for combat, health, max health, attack power, etc. In the following practices, we'll define variables and use them with some familiar functions to make our code more readable. Let's give the 4 here a label so we know what it does. A variable called angular speed. Oops. There's something wrong with the code here. Can you see what it is? Run the code and read the area corrector code and see if it works as intended. Not declared in experience code. In the previous lessons, we decreased and increased characters' health, but there is no limit to how much health they could have. As a result, the player could increase their character's health indefinitely, which we do not want. Why not? It's great. See? Look at them. They have so much health. What happens to health when we damage our character? Suppose our character has 100 health. What would the value of the health be if we called 5 times? I mean, 25 times 5. That would be minus. We can use conditions to run actions selectively. Conditions make your code branch into 2 paths. If the condition is meant, computer run. So are we going to do if statements now? Yes. Video games, other kind of computer programs are full of conditions. For example, law. Computer checks conditions. This is called to elevate a condition. All conditions elevate to either true or false. Either player is pressing the button or not. Either the character is touching an enemy or not. In our case, if health goes over a maximum value, we want to reset it to the maximum. To define a condition, we use if keyword. We write a line starting with if, type the condition to evaluate, and end the line with a colon. Okay, so you still end it with a colon though. So instead of a semicolon, they use a colon. Notice the greater than less than sign. We read the symbol as greater than. We've seen how function definitions use a colon at the end of the first line. A nest content inside in GDS script. The syntax is a recurring pattern for all code blocks. The computer knows which instructions belong to the condition because they are indented. Okay, so right here we have the heal function, and we're saying that our health is adding the amount. So if our health is greater than 100, it will be 100. And now it is not increasing further. In the average example, in the above example, in the average, we use the example greater syntax to mean greater than. We can compare numbers in other ways too. Greater than, less than, equal to, not equal to, etc. I know those ones already. That is not any strange to me. And a strange thing. Here's how we might use these if statements. What does the pass do in the code? The pass keyword prevents errors in our code when a line cannot be empty. For example, we must have a line of code after a function definition or an if block. When we don't know what to write, you can use the pass keyword as a placeholder, and go dot won't give you any errors. In the previous example, if there is nothing below if lines, go dot would give us an expected and indent block after if. Okay, so that's interesting. They have something natively to do that. Which of these statements are true? 2 is not equal to that. 1 is not 3. 3 is greater than 1. 2 is less than 3. Teaching me basic math, how cruel. The if keyword comes with a complementary else keyword. You can write an else block after an if block like so. You're slow, you're fast. So you have a variable that is speed. Speed equals 120. So if speed is less than 100, it'll print you're slow. But right now we see that's above, so if it's above, it should say you're fast. You're fast. Boom. Says you're fast. Normal stuff. I've used if statements plenty of times before, so that's nothing strange for me. Each if statement below has a wrong comparison sign. Fix the comparison sign so every condition is true and every print message runs. So if your health is 100, so your health is less than 5, health is greater than 5, so we want that to say greater than. So if 1 is less than health, boom, change it to less than, health is equal to health. And then if health is not equal to 7, pretty simple. The heal function adds amount to health, but right now health can increase forever without limit. We want to stop it at 80. I've defined a health variable for you with a starting value of 20. Your task is to add a condition inside health so that the health is never greater than 80. To check your code, I'll call the heal function twice, like this. After those two calls, health should be equal to 80. Okay, so let's see. So the heal function is going to heal an amount. So we want if well, actually I would want it to be health is greater than or equal to 80. Oh, why was I writing equal? I was writing equal. forget how you write the else statement in this. Actually, I wouldn't have to write an else statement, would I? I'd just be able to do that. Yeah, like I say, that's not what I wanted to ask for. I just write it like that. We want to display the health number on screen, like in many RPGs, but currently the health can go below 0, which does not make sense. We want to stop at 0. Complete the take damage function, so it does two things: subtracts the amount from health. If health is below 0, after that set it back to 0. To check your code, I will call your take damage function 3 times like this. After those 3 calls, health should be 0 and not negative 10 or another value. Okay, so we have health minus amount. If health is less than or equal to 0, health equals 0. Remember the colon. I mean, I don't need to write anything again. I'm going like I should make it more complicated, and it's like, wait, I don't need to make it more complicated. What am I doing? We define a level variable to keep track. The robot is at level 1. When the robot has defeated enough enemies, we call a level up function to increment the robot's level. As we briefly saw in the last lesson, a robot could have a range of variables that could increase when it levels up. And this lesson will focus on increasing the robot's max health. The variable max health is the maximum amount the robot's health can be. We can change our heal function to use this variable. We could add 5 to the max health every time the robot levels up. This would increase max health the same amount every time. If we graphed max health, it looks something like this. Max health level. Oh. This growth is linear. In our case, we want a feeling of more and more power as the robot levels up. We want a graph like this. Ooh, powerful. That's an interesting way to show the game design, huh? The growth is exponential. With each level, more max health is added than the previous level up. To get exponential growth, we multiply the max health by an amount greater than 1 each time the robot levels up. To multiply values together, we use the multiply sign. What is the value of damage? Okay, so level is 5, power is 3. Calculate damage. Damage equals level times power. So 5 times 3, right? 15. Me doing basic mathematics. We can use the times equal in the same ways that we did minus equal and plus equal. What is the value of damaging now? Okay, so 30. That's an interesting way to do that. I guess it's not something I always think about, but I haven't programmed enough. A lot of the stuff I programmed was like walking simulator type stuff, so I never really had to think about as much statistical values for the variables. Even though it's basic, but I never really had to use a multiply equal. Incremental multiplication. Let's level up our robots and add exponential growth to max health. And the practices, you'll increase the robot's max health and add a special ability to our robot to make it extra tough at higher levels.
So tough, bruh.
Let's make the robot stronger when it levels up. Add level up function. So it does the following. Increases level by 1 and max health by 10. Okay, so level increases. It doesn't say do the oops. 10. By 10%. 10%. I mean, 10% of 100 is just 10%, right? Just 10, right? I don't know. I think that's right. I don't know percentages. I'm stupid. Oh yeah. Max health is correct value. Right, but multiplication is being used. Wait, it doesn't say that it should be 120 anyway. The heck? How do they write it? Oh, okay, they do the percentage like that. Interesting. So I did everything right besides that. We did everything right. And still it's come to this. I guess they assume most people that do this probably are good at basic math, but they didn't know I was coming here. When our robot's level is 3 or more, we want it to take a lot less damage. And to the take damage functions, the following happens. If the robot's level is greater... I also feel like they don't tell you enough of what you want. Like, they didn't tell me how much health I was supposed to have for the other one. That was kind of weird. Okay, add the take damage function, so the following happens. If the robot's level is greater than 2, reduce the damage amount by 50%. Okie dokie. If the level is... well, greater than or equal to 2. Let's see, what is 50%? 0.5? Is that right? I guess I'd be right like that, but... wait, what is the damage value? Didn't I just write this exactly how they have it? Is it just the order of operations, not the not operating? Right, that would make sense. Order of operations is important. Don't be stupid. Can be a little stupid. Before you come across two variables in the course which are vectors, which are they? Position and scale. Vectors are great for games. Vectors are essential in video games. They allow you to represent a character's movement and direction, calculate distance to a target, and more, with a little code. Take this turtle AI below. You've probably seen games where you move like this. This is done with just 7 lines of pure vector calculation code. The code is a bit too difficult for now, so we'll spare you the details, but this turtle gives you a glimpse of what 2D vectors can do for your game projects. Probably wanted to move slower than that, but... We scale the robot again, this time by adding it directly using a vector 2. The following code has the same effect as the previous example. It checks the new vector 2 with its x set to. Okay. Using vectors to change position, we can add and subtract vector's position because it's a vector. If we wanted to move our robot to a new relative position, we'd add a vector 2 to its position. "50 pixels to the left." Yeah, because the vector 2 is doing that for us, so we don't need to write that. It'll be the same thing, kinda. I haven't used vector 2s in a while. Add a code to the level of function to increase the scale of the robot by vector every time it levels up. Okay. Now see, I wish they had the terminology right in front of me. I feel like I would just make a notepad for myself, but now I'm just like, what are we calling it? Scale? Okay. That's kind of funny. The robot's level has increased a lot, so it has size. Let's fix this by resetting the robot's scale and position values. Create a function named I am not writing in the box. Oops. Scale position. interesting. You've seen that you can use functions to reuse code. In this lesson, you'll learn about loops. So this would be enumeration, right? This would be wheres, and etc. To illustrate how loops work, let's take a look at a game board split into a grid. Our robot can move to its neighboring cells by changing a vector2 variable named cell. It represents the current cell the robot's in. When you use cell X, the robot moves to the right. Move to the right. Boom. Above the code works predefined board with a size of vector 3, 3, but the move to unfunction wouldn't work if the size of the board was different. The robot would either stop before the end or go too far. To implement a general solution for all board sizes, we can repeat the robot's movement until it gets to the end. For code that repeats, we can use loops, using while loops to repeat code. This is something that I usually had trouble with. I think it would be good to learn more about while loops. You can use while loops to make the computer repeat a block of code until you meet a specific condition or decide to break from the loop. Here's how we use a while loop. So we have while 0 is less than 4, we print a number, and then we increase the number. We use the variable number to keep track of how many loops the while loop completes. Each time we go through the while loop, we add 1 to number. The while loop keeps running for as long as the condition is true. In this case, it keeps running while number is less than 4. You can see that following code is executed 4 times in the console. Let's apply this to move to the end function. This time, we compare the number of loops to a board width. We go through the loop until we reach the width of the board. Note that we move the robot until its position is 1 less than the board's width because we are counting tiles from 0. A board of 3 by 3 cells would have cell coordinates going from 0 to 2 on both x and y axis. Cell X, board size, etc. While loops can cause issues. If you're not careful, your while loop can run infinitely. In that case, the application will freeze. Take a look at this code example. What would happen if the computer tried to run code above? So this is saying, well, 0 is less than 10, draw a square. It would draw squares infinitely until the program is terminated. When to use while loops. At first, you will not need while loops often. Even the code we show here has more efficient alternatives. Also, there's a safer kind of loop for loops, which we'll look at in the next lesson. Yet while loops have important intermediate and advanced level uses, so at least you need to know they exist and how to use them. We use while loops every time we need to loop an unknown number of times. For example, games run in a loop that typically generates 60 images per second until the user closes the game. This is possible thanks to while loops. There are other good uses for while loops: reading and processing a file like a text document line by line, processing a constant stream of data like someone recording audio with a microphone, reading code and converting instructions the computer understands, various intermediate and advanced level algorithms like finding paths around a map for AI. Let's practice some while loops, as they're useful to know. It's also an excellent opportunity to practice 2D vectors. Then we'll move on to the safer for loops in the following lesson. Okay. The robot has decided to stand at the top of the board. Your job, if you choose to accept it, is to move it down to the bottom row Complete the move to bottom function. To do this, we store the robot's position in a variable named cell. The variable starts with the value vector 2, 0, meaning the robot is in column 2, row 0. Row 0 is the top of the board. Board size is stored in a variable named board size. It contains a vector to value. Use the while loop to move the robot one step at a time, so the function works for any board size. Now see, again, I don't understand why they don't tell you, like, all of the variables, realistically. Like, they don't tell us to use board size, etc. I just find that weird. Lesson seems a little sloppy in that way. Because then it's like, well, I don't know what you want me to use, so I have to look at this to see what you want me to use. Well, cell Y. And it's like, for me, looking at it and typing it out, it still helps me in general. Right, then board size or board size? Boom. I feel like there's some better ways they could have explained those ones. I feel like they probably should show all of the variables and stuff, among other things. Makes it a little confusing when they present it that way. Anyway, for loops. In the last lesson, we looked at while loops. We found they were useful if we don't know how many times we should repeat code. But while loops can result in infinite loops if we're not careful. For example, the loop below never ends because we never increment number. There's a safer and easier kind of loop, the for loop. We'll look at it in this lesson. Unlike while loops, for loops don't run forever, so you're much less likely to get into infinite loops bugs in your game. We recommend using for loops instead of while loops because of this. For example, I changed the code above to use a for loop instead. The loop below will change the cell 3 times. Let's explain what's going on here. Code has a helper function, range, calling range. N creates a list of numbers from 0 to n minus 1. So calling range 3 outputs the list of numbers 0, 1, 3. And range 5 outputs 0, 1, 2, 3, 4, 5. Well, 4. Because it starts at 0. How for loops work. In for loop, the computer takes each value inside a list, stores it in a temporary variable, and executes the code in the loop once per value. So in this one, it's for number in range of 0, 1, 2, and I'll print number. So we get all those values. Let me build an example. Each item in the list, 0, 1, 2, Godot sets the number to the item, then executes the code for loop. We'll explain the arrays more thoroughly in the next lesson, but notice the number is just a temporary variable. You can create it when defining the loop, and the loop takes care of changing its value. Also, you can name this variable anything you want. This code behaves the same as the previous example. In both examples, we print the value of the temporary variable we created, number in the first example, elements in the second. Moves through the loop, it assigns each value of the array to that variable. First, it sets the variable to 3, then to 5, and finally 7. We can break down the instructions of the loop runs. You can see how a loop is a shortcut to code that otherwise gets long. Okay, using a for loop instead of a while loop. Here's our old move to end function, which used a while loop. If we use a for loop instead, the code becomes a little simpler. I don't know, it's technically longer. It just doesn't use the less thans. With the for loop, we check the board's width. Then we move the robot that many times. This is simpler than checking if the robot reached the end of the board over and over. The function still works the same way, assuming the robot starts at cell X. 0 each time. The left edge. The while loop would work no matter where the robot starts. You can run it below. Okay. Once again, the robot has decided to stand at the top of the board. That pesky robot. This time, use a for loop and the move to bottom function to have it move to the bottom of the board. The board size is determined by vector variable named board size. This is when it starts making my my brain thinky. Going like, wait, can I do basic now? Let's see. That's pretty good. Let's see. Okay, let's do basic thinking. Wait, did I forget to get that? Okay, writing plenty of stuff. Because I could remove that one. You know, I forgot that I didn't make the web page more seeable. This whole time, wasn't thinking about that. That's kind of funny. Where's the web browser? Okay, there we go. Can't believe I did that to myself. Anyway, the thing I was complaining about is they don't tell you, like, enough information to be able to do this, which is annoying to me. But anyway, so we're trying to move to the bottom. So for speed's sake, we have taken the solution code. So we have 4 number in range board size. That's y minus 1. And then we just travel. Oh. I don't even know if my brain likes how they wrote that one. Use a for loop to remove the duplicate code in the run function. So this is like the one that we did last time. Square. We need 3. We're going to make 3 squares. I mean, we would just take the same thing, right? Yeah. We just put that there. And delete that. There we go. Creating arrays. The range function we saw in the previous lesson outputs a list of numbers. Calling range 3 produces a list of numbers 0, 1, 2. List of numbers or otherwise has a precise name and code. We call it an array. So we can say calling the range function produces an array of numbers. We could write and use that array in our for loop instead of the function, instead of the range function. You can run the next function step by step and see how it works. Okay. If we unroll for the for loop above, we'd get the following code with the exact same behavior. Right? Write the arrays in this way. You start with an opening square bracket, then you write comma, separated values that can pose the array. Finally, you need closing bracket to complete it. Just like a number vector, we can assign arrays to variables to reassess them later. Excuse me. In computer programming, we use arrays all the time. Precisely, you use them whenever you need to store a list of things. You always need lists of things in games. Player's party in an RPG, the items in a player's inventory, high scores in an arcade game, the objects in the game world. All of those and many more rely on arrays, using arrays to follow a path. Let's look at the widespread use of arrays in games, finding and following a path. In games, you need allies or monsters to find their way to the target, whether it's the player or some point of interest. To achieve that, we use a path-finding algorithm. As the name suggests, those algorithms find the path between the 2 points and allow the AI to traverse the game. Many of those algorithms use arrays of vector 2 coordinates to represent the path. Take this turtle pet who wants to follow the robot, but there are rocks in the way. How can we tell it's where to walk to reach the robot with an array? Each value in the array represents cell. Interesting. But the actual part you would want to know is to do this automatically and not have to calculate it every time. Turtle wants to meet the robot, but it cannot find its own. Fill the turtle path array with vector 2 coordinates. Okie dokie. Annoying. Keep breaking my spacebar key. Three one and Okay. Now they tell me. Oh, they only want me to make the value? Oops, that one wasn't capitalized. No, I was just writing the array. Ah. In this tactical game, the computer can select multiple units at once. You need to call the select units function and pass it an array of vector 2 coordinates to know which units to select. Each vector 2 in the array represents a cell with each unit. You can pass arrays and function calls as arguments, as an array is a value type that the computer recognizes. You can pass whole array as a single function argument. I mean, I don't really want to write it all, so... I guess it's interesting to know that you can write it like that, though. You can make it like the list, you don't have to make it all one line. It's good to know. We use the range function in combination with for loops. Yes, we've been doing that. What will this code print? Okay. In a condition, the in keyword allows you to check if the value exists in an array. The array's append function appends a new value at the end of the array. Notice the use of the period after the selected units variable to call the append function. It's because this function exists only on arrays. When the function exists on a specific value type, you write a dot after the value to call the function on it. We'll revisit those two features again in the following lessons. The beauty of loops is that they work regardless of the size of your arrays. The code just works whether you have 1 or 10,000 units to select. It's all accomplished with only a couple lines of code. That's the power of computer programming. That's the power. In the following practices, you will use arrays to combine with for loops to achieve similar results. Okay, our AI pathing algorithm provided a path for the robot to move to the right edge of the grid. Your task is to use a for loop to make the robot move. To move the robot, we'll call its move to function Like so. Robot move to. So just do that, right? Right, do I have to put another semicolon there? No? Oh yeah, they wanted me to loop it, right. Right. I don't know what I'm doing anymore, apparently. Immediately don't know what I'm doing. Only just started. But wouldn't that be neat? I'm pretty sure that would still need to be written differently anyways, realistically, right? Use a for loop. Draw every rectangle in the rectangle sizes array. The draw rectangle function. Rectangles shouldn't overlap across each other. To avoid that, I'll need to call the jump function. I guess I have to write sizes specifically. But what is it supposed to be? I definitely feel like I could have written that better. Oh. Wrote it wrong. Well, we don't got that many left. Might as well just finish it all, right? We don't have to draw many rectangles, something surprisingly common in games. Did I not just do that? Oh, sorry. Went to strings now. Okay. Every piece of text you see in this app is a string that Godot is displaying for us. Much like how vector2 variables make the calculations easier, string variables come with many helper functions and tricks we can use. We can use arrays to store strings too. This is useful for changing animations. In this example, the play animation plays a specific animation. Okay. Let's change their name to Greg. In this practice, we'll chain together animations using an array of strings. You might find such combinations in fighting games. The robot has the following animation names. Jab makes the robot perform punch, uppercut, powerful jumping punch. Find the combo variable at the top of the script. Then in the run function, that's not how you do it. What am I writing? I need to specify that better. I don't like that. They don't say call it animation name. So I don't know why they... it's just annoying. Excuse me. Till now you learned that functions are a way to group instructions and give them a name and reuse them. Functions can also make calculations and return new values. Round function gives you back a new whole number rounded to the nearest digit. Imagine you have a game where you check the player's health as a percentage, a decimal number going from 0 to 100. When displaying the health on the interface, you don't want to show a decimal part. In that case, you may use the round function like so. Notice how we assign the result to the function to call a variable, because the round function returns a new value. We need to either store the result in a variable or use the value immediately. If you need to use a return value more than once, start the variable first. Otherwise, you can use the function call directly where you need it. Lerp. I know about lerping. It's all floaty. A lerp function, short for linear whatever, blends between two values. It takes 3 arguments, a start value and end value, and a blend amount between 0.0 and 1.0 that controls the blend. A value of 0 gives you a start value halfway between them. In games, lerp is often used to make things move smoothly towards a target. A code example, I wrote the lerp function call across multiple lines for readability. This works exactly the same as writing it on one line. Yeah, so you make your position, and position is dependent on the mouse location. So when I have it here, it smoothly moves to where the mouse is. Every frame, the code calculates position somewhere between the turtle and the mouse cursor. The lerp function takes care of everything. It's not the most robust approach for smooth movement, as you'll learn in the future, but it's a helpful function nonetheless. Writing a function that returns a value, and you can make your functions return values. To make a function return a value, you can use the return keyword followed by the value in question. Previous lessons we had characters walking on grids. For those practices, you are working with cell coordinates like vector 0, 0, vector 2, 1, but cell coordinates are not the same as positions on the screen. A cell coordinate like 2, 1 tells us which cell we're in, but not where it is in pixels. To draw something on the screen, we need a pixel position. We can write a function to convert cell coordinates to pixel position, however, hover over the cells below to see how it works. So they times it by 120, 120 to get the pixel position. To convert cell coordinates to pixel positions, we multiply the cell coordinates by the size of each cell in pixels. For example, if each cell has 120 in pixel, wide and tall, then it's at the pixel position 120. Yeah, because if it multiply, it would be by itself. Okay. So we can store it in a variable and use it right away. Convert to world coordinates cell. So return cell times cell size. Okay, the x value goes to the right, the y goes to the bottom. An example below we call store the return value in a variable. Some functions return values and some do not. You can check this in the documentation panel during practices. Want to practice these specific functions, the panel shows information about them. In the documentation, functions that start with the word void do not return a value. Any other word before the function name means it returns a value of that type. You'll learn more about types in a couple of lessons. For now, let's practice turning values from functions. Function takes vector 2 cell coordinates as an argument, like vector. It should return the pixel position top left corner. We'll call it convert around 3 times in total with 3 different cell coordinates to test your code. Yeah, just asking me to return the cell times cell size. I feel like this goes on too many assumptions that I don't enjoy. I don't like the assumptions it goes on. I think it makes it a little more confusing than it needs to be. Ow! Pulled my headphones on accident. You can append function to add values to the end of an array. To remove values from the start, you can use the pop front. The value jumps out of the array. Try to read the code below before moving on. Don't worry. If everything doesn't make sense, we'll break it down. So we're waiting on orders, completed orders. They're both in an array. So when we're adding orders, pretty much we'd have like a list of different meal names, right? And then we go waiting orders, append meal name 1, for example. I feel like you just want it to be another array, right? Complete current order, and the first order equals waiting orders up front. Functions like append and pop front only exist on arrays. We call them, we need to write the array name, then a dot, then the function. Let's break down the code. We add orders to the waiting orders array, appending them. Get this part. We use an array. The array of stacks. Take a factory management game where you need to retrieve materials from stacks or crates. They arrive at a factory piled up vertically and you need to take them from top to bottom. To take a crate from the back of the array, this time we use pop back array function. This function removes the pop, turns it to you. Here the pop to the array. Where's the value? When we use an array this way, we call it a stack. The last element we add is the first one we remove. Like a pile of plates where you take from the top. Okay. Do I just zip through these the easy route? Your job is to move orders from waiting list to completed orders list using the array's append and pop function. Array's pop front function returns the pop value, allows you to store it in a variable. Waiting orders P. Oh, pop front. Okay, that makes more sense. Okay, so completed orders is a variable. So you're saying for variable completed orders, it equals the waiting orders list. We're using the pop front function to return the popped value, which allows us to store it in a variable and then pass it to another function. So now we can pass that to another function, and we do completed orders, append completed order. I still feel like they could show that in a better way, because almost like 99.9% positive you can't do it like that for real. That one's pretty simple. You learn to loop over all the values in the array using the for keyword. What if you want to access the last or second before you're at -1 backwards, you'll catch with this syntax: if you try to access an index that does not exist, you'll get an error. You have to be careful to always. Okay, that's normal. Array comes with a member function named size. You can call it array anytime to know its current size. In our game, the player has an inventory that works as an array under the hood. The player knows they have a sword and a shield somewhere in their inventory, but they don't remember exactly where. You can use the inventory drawn on the right along with the current index of each item in inventory. Your task is to find one sword and one shield in the array using their index. Then use item on each one of them so the player can equip those items. The first item in the array is what you need, you would call use item inventory 0. Okay. Interesting. We've train tracks broken down into little chunks. We use them to make our modular tracks and draw circuits. All the shapes and sizes, however, several chunks are misaligned. You need to find them in the tracks array. Pass them to a line function. Eh. I don't want to do that. Write it for me. I get the point. I want to learn things I don't know. Creating dictionaries. In the last lesson we used an array to represent the player's inventory. With just an array of item names, though, we can't easily keep track of the amounts of each item. Instead, we can bundle the item names and amounts into a single dictionary. Dictionary is a data structure that allows you to map pairs of values. In the pair, we can call the first value a key, as we use it to access the second. In other words, a dictionary has a list of keys, and each key points to a value. To define a dictionary, we use curly brackets. A colon separates each key and its value. A comma separates each key and a value pair. Dictionaries can hold any values, and map any value to any other value. We can use the name of an item as a key, and the amount as the corresponding value. This makes dictionaries excellent for keeping track of players' inventory. Here we matched the name to an amount, but a key could be a string, a number, or even a vector. Although we could have all of those different keys, keep in mind that every key has it to be unique. That means we couldn't have a dictionary like the following. In the other example, which key would cause an error? Accessing values. We access the value of keys by writing dictionary name with key between square brackets. How do you access how many gems the player has? Dumb, that one has the S. You can also change the value directly, which is useful in our cases, adding or removing items to the player's inventory. Following process will use the dictionary to create player inventory and create a function to change the value of items. Oh boy, I don't want to read it. Let's give some items to the player. Okay, I mean that's just variables, nothing would actually come up in reality. We want to change the name, change the item counts in the player's inventory. Okay, I mean that's pretty simple. I feel like these ones kind of get worse at showing you how it works. Displaying an inventory's content. To display the player's inventory, you need to know what it contains, the name and the amount of each item. To do this, you leap over the dictionary and process each key value pair one at a time. You can get the list of all keys in the dictionary by calling keys function. name you choose yourself. You can call it item name, item key, or anything else. This variable holds one key at a time. As the loop runs, you can get each value with a syntax dictionary key, as learned in the previous. Item name in inventory, variable item counts, inventory item name. Then you want to print the item name and the item count. Use the dictionary to store the player's inventory. The keys have the name, the values are how much. Leap over the dictionary and display every item in the inventory. Call the display item function. It takes two arguments, the name and the amount. So for all the items in our inventory, we want to continuously display the items. We want to say the item's name and the number of them. And when we're looking at the item count, we're looking at the inventory, looking at how many item names there are. We have dictionary named units. Yeah, still don't really like those ones that much. They said I didn't do the practices because I skipped over them. Oops. So the following code looks like it here. You can also convert strings into whole numbers or decimal numbers using respectively the int or float functions. Those functions can convert what the player writes in a text field into a number, for example, the number of potions to sell at one shop. Player input 10 as a whole number. Most types are incompatible. For example, you can't directly add or multiply an array with a number. However, some types are partially compatible. For example, you can multiply or divide a vector by a number. This is possible because other developers define that operation for you under the hood. However, you cannot directly add or subtract a number to a vector. You'll get an error. That's why in earlier lessons you had to access sub-variables of positions to add numbers to them. Take the following division, 3 divided by 2. What result would you expect to get? 1.5? That's because for the computer, the division of two whole numbers should always result in a whole number. When you divide decimal numbers, instead, you'll get a decimal number as a result. Even if it's just a 0. Adding a decimal place tells the computer we want decimal numbers. Okay. So you can make it a float. Or normal number that way. Interesting. Yeah. Okay. In our game shops, we want to let the player type in numbers. So we'd use that stuff, but then we're going to add the item count in and change it into an actual number. So the program can calculate it. It's interesting that it does it automatically like that. C# doesn't, so that's kind of neat. Some text. And dynamically typed language, that means that you can just write variables, assign them a value with a number, and assign them another value with a different type. Time values type float doesn't match. Okay, interesting. I can computer figure it out. Comes with a feature called type interface. The computer will set the type using the value after the equal sign. You can make a variable of type vector 2 like so. When you give the language hints like that, it'll prevent major type errors. You can report issues as you write the code. It makes the benefit even greater. Type hints can also improve the readability of your code. It can help to put more information directly in the code. As we saw, types are essential when coding, and when using type hints, the computer will add them to the engine's built-in code documentation system. Okay. Oh, they just wanted me to correct this, right? Going too fast. Too darn fast. Pie. I'm gonna do it myself for repetition. An actual game? Not available to order. 4 courses. It costs money. Well, I at least learned some stuff. I have been streaming for like 5 hours now, so I'm gonna stop here for the day. Take a break, eat stuff. I might start doing a little bit on my own for this game I'm gonna be working on, but at least for now, I went through and did that little basic course, got some of the basic ideas down. A lot of it is like C#, so that's nice. The wording is a little bit different, so I'll have to get adjusted to that, but I'm glad to know that it's not too different. I at least know how to read it, essentially, now. I always get myself confused on loops, but that did help a little bit. I probably should always refresh on that, though. Either way, I'll probably work on this again by at least Friday. Tomorrow I would like to do more Digimon Survive. Hopefully I will do that. So until next time, we will catch you later. Johnny. I always have to remember to turn off my music first before I do the end thing. Now it has ended. You can go home.